Nowadays, there is a tremendous increase of global air traffic to fulfill the rising demand of transportation. The need for greener aircrafts is at the same time larger than ever. These goals can only be reached by full integration of lightweight design in novel aircrafts. The European research project ComBoNDT addresses these challenges by developing advanced NDT methods for quality assurance concepts for adhesive bonding of aircraft composite structures.
Composite materials have very good mechanical performances, meanwhile being lighter than conventional metallic parts that we are using in aeronautics. In addition, they can be designed and optimized with regard to the expected loading. All that taken into account, you can have lighter structures with better mechanical performances and at lower cost. And it leads to a better eco-efficiency of our product, our aircraft. Today the main showstoppers is a weak bond issue. A weak bond is a bond whose mechanical strength is below nominal strength. It can be generated by the presence of a surface contaminant or deviation in curing process. So for a wider use of bonding for production and repair application, we really need a solution to weak bond issue.
Due to these challenges, ComBoNDT project is dedicated to the preparation and testing of defined adhesively bonded samples. For sample production, contaminants that are relevant for aircraft production and repair have been identified and used. Clean and contaminated samples were then used for measurements with surface characterization methods and bond line non-destructive testing devices.
The first and very important and critical step is the preparation of samples with defined surface states and defined bond line quality. Only by having these samples we can improve and adapt the technologies in the right way.
At the same time, additional samples were prepared for destructive mechanical tests.
The results from mechanical tests reveal that both surface contamination and environmental aging reduce significantly the strength of adhesive joints. The most commonly used test methods for the mechanical characterization of adhesive joints are the Mode 1 and Mode 2 fracture toughness tests. Although these tests give representative information for the strength of the joints, they are very complicated, time-consuming and too expensive. In ComBoNDT, additionally to these tests, we have also used the novel centrifuge test, which was proved capable of capturing the effects of the different contaminants. We can conclude that it is very important, from one hand, to ensure high production quality of adhesive joints, and from the other hand, to develop extended non-destructive testing techniques which will be capable of capturing the kissing bonds which are not detectable at the moment. Moreover, the development of extended non-destructive test techniques will contribute to the ongoing effort for the certification of adhesive joining for use in primary aircraft structural parts.
In order to demonstrate the technological improvements and the increased DRL level of the ENDT methods, a demonstration on realistic aircraft parts is indispensable.
During the demonstration days, all the project partners test and use their advanced ENDT techniques on realistic aircraft parts. This is a very important step towards the use of these techniques in real industrial applications.